So this is video 4.2c, and we're on example 3. And one of the things about graphing all of these that you'll notice is that you don't really have to understand what it's going to do vertically, horizontally, the different shifts, how the amplitude is going to change, how the period is going to change. All you have to do is follow these methods to graph it, and the graph will take care of itself. The graph will naturally be where it's supposed to be. You don't have to be able to figure out all the different phase shifts and everything. You just graph it. So on the one example number 3, it's y equals -2 cosine 3x plus pi, and it's asking you to do this over 2 periods. So what you're going to do is you're going to do this like you normally do with 1 period, and you're just going to extend it a little bit longer. Doesn't really matter which side of the graph you extend it, but you just make 2 of the same graphs side by side. So if you got a graph like this and it said do it over 2 periods, well, just draw another one. Now it's over 2 periods. So let's go ahead and do this one. Again, we're going to find out for sure what our period is, as well as, well, I know this is 1 period, and it's easy because 1 period is 2 pi. We're going to have a period of 2 pi because there's no number in front of here. I've got some other stuff in here that are going to make some changes from where it normally would be, but we're just going to graph it and do the work just like we normally do. So we know it has a phase shift, so we're going to take 0 as less than 3x plus pi is less than or equal to 2 pi, which is our period. We're going to subtract pi, and over here we get a negative pi, we get a 3x, and we get a 2 pi minus pi is 1 pi. So now I need to get rid of this 3. So my interval is, it starts at negative pi over 3 and ends at positive pi over 3. Alright, so that ends up being where my graph is going to end up being. Okay. So let's get rid of the work and move this up so we've got some room to work. Okay, so now we're looking for the halfway point, the quarter, and the 3/4. So 1/2 times negative pi over 3 plus pi over 3 would be 1/2 of 0, which is going to be 0. So my middle here is going to be 0. Now I'm looking for the middle of that. So that'll be 1/2 negative pi over 3 plus 0, which is going to be negative pi over 6. So negative pi over 6. Now we're going to find the halfway there. Alright, so the halfway there is going to be 1/2 0 plus pi over 3, which equals 1/2 times pi over 3, which equals pi over 6. So we're going to put pi over 6 in here. Alright, so those are my x values. Now I'm going to take negative pi over 3 and put it in here, multiply it by 3, add pi to it, take the cosine of it, multiply it by -2, and I'm going to get a y value then of -2. And when I do the same thing with the negative pi over 6, I get 0, here I get 2, here I get 0, and here I get -2. So I'm not going to go through all the tables. You've done these over and over and over again. So again, I take the negative pi over 6, put it in here for x, multiply it by 3, add pi, take the cosine of that, multiply it by -2, and get 0. So then when I graph this, I have as my amplitudes 2 and negative 2, because that's what my y values are. My largest y values are my amplitudes. In fact, what I should get is always my amplitudes and zeros for my y value, unless it shifts up or down. Okay, at this point we haven't done that. So that means we have negative pi over 3. At negative pi over 3, we are at, get a good color here, we're at negative 2. At negative pi over 6, which is going to be here, we're at 0. At 0, we're at 2. At pi over 6, we're at 0. And at pi over 3, we're down at negative 2. So this is one period, and it said it wanted 2. So we'll just kind of do that, and do that at both ends, and we're done. Or you could have just continued this down and gotten 2 periods out of it. Okay, so let's work on vertical translations now that you have the horizontal translations figured out. Vertical translations are going up or down. So what we're doing with that is, let's look and see what we've got here. C plus a sine. Let's do cosine. That's what they're doing. Doesn't really matter. Everything happens the same. Alright, so let's look and see what this does. This determines the amplitude. This determines how big the period is. This over here will determine how up or down on the x-axis will go. Instead of using that x line as kind of our midpoint, this will shift that midpoint up or down that many. So we're going to do everything the exact same. We don't even care about the vertical translation. We're just going to follow the rules that we've been doing all along, and when we make our little tables, everything will work out. So y equals 3 minus 2 cosine. It's just our tables get bigger. Alright, so first thing we're going to do is what we've been doing all along. Find out where in the world this thing's going to go. Is it going to shift left or right? Is there any kind of a phase shift? No, because there's no number added or subtracted to this. So there's no phase shift at all. So we don't have to worry about what we did before, where we would have 0 is less than or equal to 3x plus pi, which is less than or equal to 2 pi. We don't have to do that because there isn't a phase shift. There's no number added or subtracted to the x, so we don't have to worry about that. But what we do have to concern ourselves with is this part right there. That's the b part. That tells us our period. So we have to use the 2 pi over b, which is 2 pi over 3. That ends up being our period. So our interval then is 0, 2 pi over 3. Oops. So now I have to take 1/4 times 0 plus 2 pi over 3. 1/2 times 0 plus 2 pi over 3. And 3/4 times 0 plus 2 pi over 3. So actually we could just erase the zeros there. This one I'll just scribble out. So this we have 2 pi over 12, which is pi over 6. This one's 2 pi over 6, which is pi over 3. And this is 6 pi over 12, which is pi over 2. So my intervals are 0, pi over 6, pi over 3, pi over 2, and 2 pi over 3. Alright, so we have our end here, here, and then our halfways in here. So notice I can use this formula here when I don't have any phase shift. When I have a phase shift, I have to do it like the other example, example 2. So it makes it kind of nice when there isn't that phase shift. Okay, so cleaned it up, put my intervals on here, and then we just start making the table. We take 3x, then we take the cosine of 3x, then we multiply 2 times the cosine of 3x, then we write it as 3 minus 2 cosine of 3x, and we keep filling in our spaces. So this one right here is actually my y value because it says that y equals that. So let's go ahead and just call it our y value. And so when x is 0, our y is 1, and then we've got a 3, and then we've got a 5, and then we've got a 3, and then a 1. So let's go ahead and graph that. And let's see if we can move some things around here. Let's move those together. So these are my x's, and I'm going to get rid of that. Those are my x's, and my y's again were, oh gosh, 1, 3, 5, 3, 1 when I put all the information in there. Okay, so then I graph it. So when x is 0, y is 1. When x is pi over 6, y is 3. When x is pi over 3, y is 1, 2, 3, 4, 5-ish. X over, or pi over 2, we're at 3. And at 2 pi over 3, we are at 1. So here is my graph here. So actually, it should look more like that. And again, it said do it over 2 periods, so you know, by the time you do that in green there, you've got your 2 periods. So that's it for this video. We'll have one more.